Live.
Awesome.
So, do you have any questions or anything that was, or how did you think about this assignment?
The only thing I'm having a hard time with is what we use alpha for.
This is the exact same question I had.
Like, I did the reading, I watched all the videos, and they just kind of use it, and then like it doesn't show a use to me, and I don't really understand how they used it or how they applied it to get like a decimal point or whatever they're going for.
Yeah, I was just cause I was trying to read it last night at work, and like half the stuff wasn't showing up, so I was just rereading it, and like I don't see, like it tells you where, like what it is and like what it stands for, but it doesn't say, like, well, here's the formula and where to use it.
Yeah.
The only thing that says is under 4-4. It says if the p-value is less than alpha, we reject it, and if it's greater than alpha, we reject the null hypothesis. We fail to reject the null hypothesis. But I'm assuming we just use 0.05 as the standard for the course, and if the p is lower, then reject it, and if it's greater, we fail to reject it.
To be honest, that's fair logic from all the information we have.
Right.
Yeah, I just don't feel like it was very straightforward about how to use alpha.
Yeah,
that's the only thing I'm like, I don't know. So
yeah. That's kind of the only thing that I got from it, was that it's just there, and I'm assuming for the course it'll tell us what we're going to use or what the value of alpha is going to be, which I'm assuming for the most part is going to be this 0.05 they talked about. And then we'll see if the p-value is greater than or less than, and if it's less than, we reject it. If it's greater than, then we fail to reject it. But this chapter in general for me was just very confusing. Like, it was just back and forth, and you don't not accept it, but you just don't reject something, which seemed weird.
Like, I'm not confident in my ability to determine what type of rejection it is either. Like, I understand it. I think I'm just out of practice, but
right.
Yeah, I don't know. You're right. This chapter felt like it was dumping a whole lot of information on us, but trying to use stuff we already knew, like the finding the z-score.
Right.
Yeah. So I don't know. Should we just dive into the quiz then? I mean,
yeah, let's dive in and see. Let's see how it does.
Okay.
Let me pull it up real quick. All right, group meeting quiz, start. All right, first two on our own.
Yeah. 3, which hypothesis involves equality? I don't remember this part.
I think it's the null.
Yeah, null hypothesis. Okay.
Which is the baseline, right? So it's saying like this is kind of the status quo.
Yeah. No, I understand. I understand null versus, but it's just I don't remember reading that part. And when I pull it up, it is mentioned twice.
Yeah, I think the way that I remember is just like the null is what it's equal to, and then the alternative is either less than, greater than, or does not equal, which means you actually don't know what you're talking about. You just don't think it knows anything.
Fair enough. Okay. Next one. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember, the p-value is the probability of obtaining a sample statistic at least as extreme as one that was actually observed. When computing the p-value, which hypothesis do you assume is true? The null hypothesis, right?
That's what I was thinking. Yeah, because you always assume the null is true unless you have information in your data says otherwise, and then you go to your alternative hypothesis.
Yeah.
So in the question 5, suppose the null hypothesis is the mean equals 10. Use this information to answer the next 3 questions. Question 5, which of the following represents the alternative hypothesis for a two-tailed test? I'm going to say it's the third one where it does not equal 10 because it can go either way.
Yeah, because the other ones are specific, one either greater or smaller than, so that's the two-tail.
And then, so hey, just so a quick question. So the first answer where it says the U is less than 10, that would be left-tailed, right? That would be left-tailed.
I read it. I don't remember.
Okay.
Yeah.
Good, because that's the next
problem
couple questions.
Is it really? Shoot, left-tailed and right-tailed.
Yeah. So
yes,
if it's less than the number, it's left-tailed. If the little u is greater than the number, it's right-tailed.
Okay.
So number 6, it says left-tailed, so it's the u less than 10, and then right-tailed would be greater than 10.
Okay.
That's under section 4.1.
Yeah, I'm reading that right now. 4.3.1. Wait, you said under 4.1? Oh, no, there it is. Okay.
Yeah,
no,
4.1 is just
right-tailed, left-tailed. Okay. Okay.
Yeah.
All right, so we're on 8. Which relationship would result in failing to reject the null hypothesis? And that would be alpha. I mean, p-value is greater than alpha.
In failing to reject, yeah.
Because if alpha is greater than it, we accept it.
Right. So if the p-value is less than the alpha, we reject it, and then if p-value is greater than alpha, we fail to reject it, which means not that we accept it, we just fail to reject it.
Yeah.
Which is, I don't know why you just say, okay, we accept it. Like, and then rejecting it's going to be the one that's less than alpha.
Yeah.
Number 9, so number 2.
Yeah. And then, okay, an insurance company is reviewing the current policy rates. When originally settling the rates, they believed the average claim was amount was $1,500. They are concerned that the true mean is actually higher than this. Use the information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis? The average claim amount is equal to, is not equal to, is greater than. So the third one down.
Yep. Question 11. Which of the following would be the appropriate null hypothesis, which is the base? So that would be that the average claim is equal to 1,500, right?
Yep, the first one. Oh, we're flying through this. All right. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Uses information for the next 4 questions. So we have 40 is our N. And X is 50. I'm guessing the 1,500 is our mean. I don't think we have a. Yeah, we don't have a standard deviation yet.
Well, actually, quick, that information that they gave us, the information they gave us for questions 10 and 11 says only to use it for the next 2 questions. So I don't think that 1,500 has anything to do with it.
You're probably right. Okay. The insurance company assumes the distribution on the sample mean is normal. Is this a good assumption?
I'm thinking A, since the sample size is large.
Yeah.
Greater than 30.
Yeah, I'd agree with that. Law of large numbers. Okay. That didn't say for some. Oh, yes, it did. There we go. Okay, 13. What theorem or law justifies the previous law of large numbers? I didn't realize I answered that one already. Okay. Which of the following is the test statistic as defined by the lesson? The test statistic is
So that's that one that
test
where is
statistic.
it? It's basically the Z-score.
Oh, so it's just Z.
Right? Isn't that what it says the test statistic is?
I don't remember that part.
Yeah, so it's under 4-2. It says it gives
It's
you the
the
little
X with the line over it is the test statistic.
Well, if you go below that, it says where Z is the test statistic, X with the line over it is the sample mean.
Oh, I should have kept reading. You're right. That's exactly right. Okay.
So Z.
All right. Yeah, Z. And then the next one, the historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. Okay, so 150, 40. The store manager suspects that the average has decreased. She set up a hypothesis test with the hypothesis, null hypothesis $150, and the, I just drew a blank, the alternative hypothesis, there we go, is greater than $150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales recipients from her store and computes $144. What is the z-score associated with this test round to 3 decimal places?
So I'm assuming our sample mean is going to be 144, and then our population mean would be 150. Our standard deviation 40, and then our sample size is 36. I got negative 0.9.
I'm getting negative 0.01. Okay, so the mean is 150. Standard deviation is 40. You're saying the sample size is 36? Yeah. And then my X is 144.
I got the same.
Oh, 0.9. Yeah, 0.9. Sorry.
You get 0.9 or negative 0.9?
Negative 0.9.
Okay. So it would be negative 0.9 for the answer.
Yeah.
So, and then 16 says, what is the p-value associated with the z-score from the previous question? Now, I'm assuming we just plug this into the applet, right? And then get the whatever the left result is.
This is my applet.
Pull it up real quick.
There it is.
So negative 0.9. And just under that, so I got 0.184. Is that what you got?
9. Yeah.
0.184.
Round to 3 decimal place. Yeah, okay. 184. And then what inference would you make about the null hypothesis for this problem? She said 0.5 was her. I'd say you'd reject the null hypothesis, but I scrolled too fast. Okay. Yeah, I'd say you reject the null hypothesis because it doesn't exceed. No, wait, no. Alpha is greater than it, so you would you'd fail to reject the null hypothesis.
Yeah, I'm looking it up again just to make sure. So, if the p-value is less than alpha, we reject the null hypothesis. So in this case, we would reject the null hypothesis, right?
That's right.
And then number 18, what is your conclusion for this problem? We have insufficient evidence that the true population mean is 150. We have sufficient evidence that the true population is 150. We have insufficient evidence that the true population mean is less than 150. Or we have sufficient evidence that the true population mean is less than 150.
Well, the sample size was over 30.
Right. And if we just rejected the null hypothesis, which is saying, yes, it's 150, that would mean we'd have to have sufficient evidence that it's less than 150, right?
Yeah.
So D?
Yeah, that's what I'm thinking with this one at least. All right, 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? That's a type 1, correct?
What is it? So it says rejecting the null hypothesis when the hypothesis is true. Yeah. Yep, type
1 error. Yep. Okay. The researcher decided that that instead of using a level of significance of alpha 0.05, he will use 0.01. Which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will be more significantly valid. My goodness, I have no idea.
So it talked in the reading that if the level of significance is less, then the probability of a type 1 error would decrease. It was not the first one. It didn't say anything about it affecting the type 2 error. I'm leaning towards number 3.
Yeah, with what you've said, I would say C.
Okay.
All right. If alpha is 0.05, compute the probability of committing a type 1 error round to 2 decimal places.
I've got no idea. 0.05, isn't it?
I would think so. Let's see.
It talks in there about how alpha is 1 out of 20. So therefore, if you're looking at 20.05.
Okay, we choose an alpha to be small. We choose alpha to be small numbers so that the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This equals to 1 over 20. So when the null hypothesis is true, there is 1/20th chance that it will be rejected at the 0.05 level of significance. Other common choices for alpha are 0.1, 0.01. I'm not seeing anything that tells us.
Yeah, I don't.
That's the only thing I can think is that it'd be 0.05. I don't recall reading or listening or watching anything that showed how to calculate the probability.
That might be what it's asking. Like, do you understand that alpha 0.05 means that the probability of a type 1 error is 0.05?
Oh, that could be it. Yeah.
All
right. Should we submit this?
Test and then see what happens.
Okay.
We missed a couple.
Yeah.
We missed 17, 18, 20, and 13.
That's it. Wait, we missed 13 as well? What was 13?
Yeah, that was the one that was a lot of numbers.
Huh. So it would be the central limit theorem then?
Yeah, because I think it's talking about the sample mean being normal.
Gotcha.
I'm gonna pull this up again and retake it.
Yeah, me too.
We missed 4. I figured we'd go through. Take an update.
As soon as it pulls up. True.
All right, so it's number 13. We're thinking central limit theorem.
Central limit. Yeah. Unless, is there anything that talks in here about the law of total probability?
I've never seen that word.
It's not in here. So yeah, it's gotta be central limit theorem.
Yeah, I just did a search.
Yeah, I did the same.
14. At 17. So it would be fail to reject the null hypothesis.
Okay. And then 18.
So with 17, I think the reason you fail to reject it 184 is greater than that 0.5.
Yeah. Oh, I see. Okay, I kept thinking it was 0.5.
That's what I was thinking too. No, as we were reading it, so it's 0.05. Okay.
Yeah. Okay, that makes sense. Yeah. All right. So
in
18.
Our answer on 18 is all based on that.
So then it would be
Insufficient evidence.
yes. Is that C?
Yeah. Yeah, because they were trying to prove that it was less than. So that's what I would say with C.
Yeah. And then, oops, 19.
Number 20.
Probably that the null hypothesis is true will decrease.
I'm assuming maybe it's the probability of a type 2 error will increase, but I'm not really sure.
I'm looking that up right now.
Because I don't remember reading anything about if one goes down, the other goes up. Actually,
okay, committing a type 1 error is undesirable. Why can't we let alpha equal 0? This would make it impossible to commit a type 1 error. Actually, this would also make it impossible to reject any null hypothesis. If alpha is equal to 0, no matter what test we do, no matter what the data show, we always fail to reject the null hypothesis. This would be pointless. So,
if you read just under that little table, the second paragraph, it says that the alpha value, the probability of committing a type 1 error is very small. The probability of committing a type 2 error will be large. So if it decreases the opportunity of committing a type 1, the probability of type 2 will
increase. Okay.
So B. And then we got the right answer, 21.
0.05.
We'll try this one.
I think I skipped some questions. Let's see, did I? No. Okay. All right.
That's a lot better.
How many do we miss that time? Mine's still loading. There we go. Okay, so we missed one question? No, I got 100% on that one.
So that was that one question affected the answer was affected another question. So that one question. So I got the one right without getting the other one right.
That's true. Yeah. So wait, you got 100% as well, right?
Yeah.
Okay, good. Wait, did I click something else?
Right.
So cool. Well,
that was
that's everything. Good luck. Have you already taken the test?
The exam?
Yeah, the exam.
Yeah, I took it last night.
Okay. Yeah, I'm just about to take it. So
okay,
I was gonna tell you good luck, but never mind. Thanks.
All right, I'll send the link over to you so you have it, and then I'll turn it in.
Sounds good. All right, we'll see you Monday. Thanks. All right, see you.